In question 3.1, we're to explain how a stationary wave is produced when a stretched string is plucked. Well, the produced wave travels to one end and is reflected. This leads to two waves of the same wavelength and same frequency, and a similar amplitude travelling in opposite directions. Where they meet in phase, they will constructively interfere. This will produce large amplitude oscillations, which is an antinode. Where they meet in antiphase, they will destructively interfere. This produces zero amplitude oscillations, a node. In 3.2, we're to show that the mass of 1 meter length of the string will be about 4 times 10 to the minus 4 kilograms. Well, we can use the fundamental frequency F is equal to 1 over 2 times the length times the square root of the tension over the mass per unit length. Squaring both sides, we get F squared is equal to 1 over 4 L squared T over mu. Rearranging for mu is equal to T over 4 F squared L squared. Putting in the values, we have a tension of 25 newtons over 4 times 370 squared times 0.33 squared. This gives 4.19 times 10 to the minus 4 kilograms per meter. This is around 4 times 10 to the minus 4 kilograms per meter as required. In 3.3, we're to find the speed of the wave. Well, for this we use v equals f lambda, frequency times wavelength, which is 370. The wavelength is twice the length, so we've got 2 times 0.33. Because basically for the fundamental frequency we have a wave like this, and the total wavelength would be 2 times that. This gives a speed of 240 meters per second. In 3.4, we're to find the higher frequency when the string is stretched by rotating the tuning peg through 75 degrees. Well, the extension will be 75 360ths of the circumference 2 pi r, and this comes out at 4.6 times 10 to the minus 3 meters. From the graph, this gives a length from going from 11 millimeters up to 15.6 millimeters, and this gives a tension from the graph again of 36 newtons. Then we can use frequency is equal to 1 over 2L root T over mu, and this is then 1 over 2 times 0.33 as the length, times root of the tension of 36 newtons now over mu, we've just found as 4 times 10 to the minus 4, and this gives a frequency of 454.54 Hertz, or 455 Hertz.